Hello and welcome to a Physical Sciences 3 lecture. We are starting a new booklet today. It is our Criterion 6 down here in Tassie, and it is the conservation in physics, which includes the conservation of momentum, conservation of energy, and also electricity in this booklet. And it has this funky guy on the front cover of our booklet that we have down here. Next comes up the table of contents, which we'll just skim over. So we're starting off with the conservation of momentum, and we are only concerned about when two bodies are colliding, so two moving objects, when they collide, they each have their own momentum. And the important bit from all this writing here are these formulas, really. So momentum, P, so P stands for momentum, P equals momentum, and it's equal to mass, the mass of an object times by its velocity. Momentum. Yep. And what you need to know is that the conservation of momentum means that the momentum before a collision is equal to the momentum after a collision. And it's easiest looked at when we have a look at examples. So we're just going to jump straight into an example. So example 1 here, we have a car of mass 600 kilograms travelling northwards at 16 metres per second, and it collides with a stationary car, so that's not moving, of mass 900 kilograms. If the cars coalesce means sticking together, after the collision, calculate the total momentum before the collision. So before the collision, if we draw our two cars, we have 600 mass moving at 16 metres per second. Then we have a 900 kilogram car, which it's at rest, so V equals 0. Okay, and what happens is the only momentum, we could calculate them both. So the momentum before is equal to m1 v1 plus m2 v2. Okay, so because it's equal to, this is our first one, so the first mass is 600, and we're timesing that by 16.0, plus 900 times by 0, so clearly this car has no momentum because it's not moving. It's got no velocity. So 600 times 16, let's grab our calculator. Go to main. 600 times by 16. And it's equal to 9,600. 9,600. And what is that in? Well, we can just call this kilograms meters per second. Okay, so kilograms is the unit for mass. Meters per second is the unit for velocity. So it's kilograms meters per second. There is another formula for momentum, which we'll cover later. So you might see that the units are also Newton seconds. Newton seconds, we can say that as well. So Newton seconds, which we'll just see later on. I find that kilograms meters per second is easiest to remember, only because of our formula of momentum is equal to mass times velocity. Okay, so that was the first part. In the second part, the cars stuck together, so we had our 600 moving along, and then it hits the 900, okay, and then they move along at the same speed, v, okay, so they stuck together, but because P after the collision is equal to P before the collision, we can just say it's equal to 9,600 kilograms meters per second. I have forgotten something. This was in a northwards direction. Northwards. So this is in a northwards direction as well. So this was moving north, and so all our momentum is going northwards. Okay, so the velocity of the wreckage immediately after the collision. So we can consider this now, because it's all stuck together, rather than an individual 600 and an individual 900, we can consider it all a 1500 kilogram mass moving northwards in some direction at some velocity v. Okay, so that means that we have P equals mv from our original one. So our total momentum is 9,600 equal to 1,500 with the mass times velocity. Now we're just seeing this divide both sides by 1,500, So 9,600 divided by 1,500. If we put that into our calculator, we get 32 and 5. Let's make that a real number. 6.4. Okay, so it's equal to 6.4 meters per second, and that would be in a northwards direction. Okay, so that's the first example of momentum. Please have a read over the notes for more detail, and we'll look at some more examples in the next lecture.